Hey guys, welcome to another video, and in this particular videos, in fact a few videos from now on is going to be about drag. Now before going through this, I would like to read few lines that is written in the book and then we'll talk about it. During flight, all parts of an aircraft exposed to the airflow produce an aerodynamic force which opposes the forward motion of the aircraft. This force is known as drag and is the air resistance experienced by an aircraft as it moves through the air. Now, aerodynamic force comprises of four forces, right? It is lift, weight, thrust, and drag. Now, basically, when we look at drag, you can call it friction, right? It is basically nothing but an opposition against moving forward, as there is always an equal and opposite force that is reacting as per the Newton's third law. When the aircraft is moving forward, there are many things that are affecting drag. It can be the shape of the aircraft, it can be the wind, it can be multiple factors, and that's what we'll be learning in the next few lessons. Now, drag as a force is acting, basically, let me draw a diagram and show you. So it is basically a force that is acting in direction or in parallel to the relative airflow, right? So I've already drawn it. Okay, so just look at the lower diagram for now. So lift, weight, thrust, which is forward motion, and there is drag. Now the aircraft is moving in this direction, right? It is moving forward, and then there is airflow coming into it. Now we can also say that this is drag and it is parallel to the flow of the air, right? So that can be a relationship, and that is one of the questions that is asked in exams these days, which is the force which is parallel to the relative airflow, and that is drag. We know what is relative airflow by now. We have spoken about it a lot of times, right? Now when it comes to drag, it is divided into three basic parts. Now, total drag acting on an aircraft can be a sum of three parts, which is profile drag, induced drag, and interference drag. So these three parts, right? Now when it comes to profile drag, it can be further subdivided into two parts. Now profile drag, if you actually look at it, it is basically related to the shape of the aircraft in itself, or the shape of the airfoil in itself, and it's a property of that, right? So profile drag can be subdivided into form drag and skin friction drag, right? So with the basic itself, we can understand that it is basically the profile of the wing itself, the design of the wing, or the shape of the wing, as you can call it, or the shape of the full aircraft in itself is related to profile drag. So in this video, I'll only be talking about profile drag so that we can go a bit deep into it. And I'll be posting pictures, because even if I draw it, it won't be as good as the diagram in itself, so that you can understand better. Now let's start with form drag. Form, or basically the shape, right? Form, the other meaning can be the shape of the aerofoil, right? So just imagine you have kept a plate, right? You are moving against the wind and you are using a plate, and there's wind hitting against the plate. Now what is happening in this particular case? What is happening is it is saying that, before that, let me read the definition for you. Form drag is produced whenever the streamlined airflow passing over an aircraft separates from the surface and becomes turbulent, right? So again, let's get back to the plate, right? So when air is hitting the plate like this, what is happening is that the pressure in front of the plate is more than the atmospheric pressure, because it is hitting the plate and creating pressure. But behind the plate, what is happening is that the pressure is below the atmospheric pressure, right? Now, what happens is, because the pressure here is lower and here is higher, a sucking motion is created and air is forced to flow like this over and above it, right? And what it is saying that this results in a sucking effect behind the plate and formation of vortices. Vortices is nothing but turbulent airflow, and it is nothing but airflow like, this. So instead of streamlined airflow, it breaks up like this. I hope you can see it is like circular, broken up. We always want a streamlined flow, right? So what is happening is that because of the form of the plate, and it's not a very aerodynamic structure, it is breaking apart the streamlined flow and breaking apart the wind and is creating a lot of turbulence, and that results in a non-aerodynamic it basically is the total reaction, as we call it, is being reduced. Okay. Now, other example that I can give you is, you have seen those undercarriage wheels. In many cases, there is like a fairing or like a cover on top of it, which looks like an aerofoil, which again increases the aerodynamic or increases the flyability factor, basically, you can say, or reduces the drag, right? So even in the diagram, in this particular diagram that is coming up, you will see that when there's a plate, you can see that the drag is too high, and you can see the graph on the side of it. So in the first case, you can see that there's a plate and the drag is very high. In the second thing, you can see that there's a ball, there is some drag. It says that there is 50% drag almost. In the third case, you can see that it's almost more like an aerofoil. So the drag is reduced to 15%. And now in the fourth case, look, it's an aerofoil and it's more streamlined. So in all these cases, in all these four cases, what you're basically seeing is that it is all manipulating airflow, right? It is manipulating airflow to be as streamlined as possible, right? And streamlined airflow basically will improve lift and reduce drag. That is what we basically want. Now, finally, before you go, I want to explain one more small topic, which is called as the fineness ratio. Now, what is the fineness ratio? It is the ratio between the thickness and the length of the aerofoil. Let's consider A is the thickness of the aerofoil and B is the length of an aerofoil, right? A divided by B, or a ratio of the thickness to the length of the aerofoil, is the fineness ratio. Now, fineness ratio again is an engineering thing. They basically use this ratio when it comes to subsonic aircrafts or supersonic aircrafts and things like that, and this ratio keeps changing. An example that they have given is streamlined shape that gives the least form of drag at subsonic speeds normally have a fineness ratio of 4:1, but these values may vary considerably, right? So basically the fineness ratio, all you have to remember is the ratio between the thickness of the aerofoil to the length of the aerofoil, and that's an engineering thing which they use basically to calculate or find out the utility of the wing. And yeah, that's it. So form drag is basically because of the shape or basically the structure of the aerofoil, and that's all you have to remember. And fineness ratio, you will remember it, I'm sure. So happy landings, guys. Cheers. Take care.